Hi there. In this video, I will give you an introduction to a command on Unix which is available on Linux also, and it's called BC. The word BC might look like basic calculator. That's what I feel the acronym is. But don't let that fool you. This is a complete programming language with all the nuances like support for variables, support for complex expressions, support for conditional constructs, loops, arrays, and so on. So you can treat it like a full-fledged language. You can also define functions in it, by the way. Yes, it has support for all of those features. But then the core focus is on performing arbitrary precision mathematical calculations. So how to get started? Well, one of the features why I'm talking BC is that BC is created with automation in mind. I'm not sure whether you'll actually write real full-blown BC programs, because there are other languages that people would look into like Python, Lua. There are so many other languages which are there. But then if your focus is purely math, if you want to do some arbitrary precision math and you're looking at a very lightweight tool that is automatable, I think BC is easy to get started. So we just type BC without any argument. It'll start with the interactive prompt. And at this interactive prompt, you can actually perform some very basic math. For example, I can say 45 plus 78. I can say 33 plus 12. I can say maybe 6 minus 3. Any of these simple arithmetic is doable. It can be add, subtract, multiply, divide. And yes, power off is a little different. If you come from backgrounds like Python, or if you even use arithmetic expansion in shell, I think the power off is done with double asterisk, right? But how is it done here? You say 2 cap 5. This is similar to a couple of languages I know about. I think Fortran is one language which supports this. Fortran, Basica. So it has the exponentiation notation with the caret symbol, the cap symbol, right? So you can use this for power of operation. But otherwise, I think most other operators are sort of similar. One of the strongest features that BC has is the ability to support arbitrary precision, floating point arithmetic. Suppose if I just try to say, want to find out the square root of 2, right? I could say 2 cap 0.5. Oh, it says runtime warning, non-zero scale and exponent, it says, right? So it's throwing some error here. It throws a warning and it gives you 1. It's not an error, it's a warning. Now there's a variable called scale. There are a couple of specific variables like scale, ibase, obase, and so on. But scale is one thing which I will focus on in this video. But just type scale is equal to, but just provide 100. And so 2 cap 0.5. Oh, even now it says non-zero scale and exponent. So it looks like this still has an issue. But there's a function called sqrt, which I'll show you right here. Sqrt of 2 will return the square root of 2 with 100 decimal points. But all let's say scale is equal to 1000 and say sqrt of 2, it computes the square root of 2 with 1000 decimal points. Now, one of the features I like about BC is the automatability. So for example, you can use it in automation rather than running in an interactive way. This is how you exit BC. You type quit to come out. Let's say I have some file, right? I just have a file. Let's just say vi.a.txt. No, already have some contents in there. Let's create something else. Let's say vi n.txt, in which I'm using Vim editor. So you can use Nano, gedit, whichever editor you find convenient with. So I'm using Vim editor this time. I can put some couple of arithmetic expressions in here. Whatever expressions, each line, right? I have individual expressions. I save this. So if you look at this file, n.txt, it's got a bunch of expressions to be evaluated. All I can do is I can say BC less than n.txt. It computes the result of each line, automated, right? So if you have a series of arithmetic to be done, you can just feed it to BC and expect the result on a line-by-line basis. That's one feature I can think of. You can also feed direct arithmetic over here. BC has support for sophisticated math functions like log, sine, cos, tan, arctan, all these trigonometric and logarithmic functions. This is available in a math library. To load the math library, you say BC minus L. So I'm going to use that in this case. This time I'm going to say This is actually there in the BC's man page. That's why I'm showing you that. It's a very interesting one. I can say echo, let's say scale is equal to, let's say the scale to, let's say 1000, semicolon. You can separate multiple statements separated by semicolon on the same line. And you could say 4 into arctangent of 1. This A is a short form for arctangent function. So arctangent of 1. And I can just say pipe BC minus L. I guess you know what this is. This is the value of pi computed to 1000 decimal points. Now, this is all done in a one-liner, right? So I'm able to feed expression to BC or BC minus L, and BC just computes the result and gives it to you this. So maybe I can actually even find out how much time it takes to execute this. Maybe by adding more numbers, I can just say maybe scale is equal to 3000. Obviously, it's going to take some time. So I'm going to prefix with the shell built-in called time. I can say time, and I want to run this entire expression as a group, as a command group. Yeah, it took about 4.5 seconds. You can actually use this technique to compare how fast your computer is with anybody else's computer. So I can actually, you can increase the scale of the numbers. If you have a very high-end computer, where you say scale is equal to 3000, if it gives you numbers like 0.5 seconds and so on, yeah, you might have really high-end computer that can do that. You can now compare it. So if you want to compare how quick or how fast the CPU is in computation, you can compare it using this. So in terms of comparing CPU's performance, in terms of doing math, this could be a very straightforward approach to check this, right? And BC has lots of other features. As you told you can perform math. You can, if all you want to do any kind of math, simple math, you can actually say echo 56 into 45 divided by 2, and you can say pipe BC. I will tell you, this is an overkill. Simple arithmetic like this, if you're using bash shell, in one of my videos I have told you that you should simply set echo double parenthesis 56 into 45 divided by 2. This is more convenient and lightweight. But if you have very complex math which requires arbitrary size precision, you want to do things like compute the sign of a value or log of value or things like that, then I think BC is useful. So it's a quite powerful tool. You can actually create variables, assign values to variables, and perform a lot of statements, just like you do in other programming language. And the way you learn how to use BC is obviously the man page. The man page is quite elaborate. It covers everything that you want to know about this particular language. It says BC is a language that supports arbitrary precision numbers with interactive execution of statements. There are some similarities with syntax in C programming language. The standard math library is available as a command line option. It tells you the complete details over here. When you scroll down, it tells you about all the switches. The -L switch, as I mentioned, defines the standard math library. But basically, it loads the standard math library. So you can use all the features of standard math library. How numbers are represented and how do you create variables are covered here. There are some built-in variables like scale, I-base, O-base. This is for changing the input-based number system and output-based number system. And there's something called last. So all of these are different entries. Last is simply a variable that contains the result of the last expression. Okay. So if you do some math and you want to have the computed result that will always be represented as a variable called last, you can actually keep accumulating into it, right? So commands start like in C language using / star and asterisk and asterisk / just like C language. So some of the syntax nuances is sort of resembling C, right? So maybe even the expressions, the ++ operator, the - operator, the pre-increment, post-increment, all these features are reminiscent of C programming language. However, if you're trying to use power off, that's a cap symbol in here. And all of these are shown here. All the relational operators and everything is covered in this. And you scroll down, it also has some very basic expressions. For example, you can find the length of an expression. You know, once an expression is computed, how many digits that expression has, you can compute that. Let me just try and check that over here. Maybe I'll just run screen. Just want to keep multiple sessions. So if I just type maybe A is equal to, or I can just say maybe length of, let's try just some numbers. Basically digits, returns number of digits. For example, if I just say scale is equal to 100 and say sqrt of 2, and if we say length of last, yeah, it tells you totally how many digits are there. 101 digits, 100 decimal points, and 1 digit which is behind decimal point, which is here, right? It says 101. So you can get all these details. Not only that, you have other features like say you have other features which involve getting input from the user. So there are expressions to get input from the user. I told you SQRT and scale of expression. You can get input from a user by using read function. So whatever you type will be fetched as user input, which should be a number, right? One thing I realized is BC, though it has a programmable language, it only deals with numbers. I don't see string operations in here. So you cannot perform things like string manipulation, right? So it's not a general purpose programming language. It's a mathematically oriented language. So you can look at statements which are there. You can have statements like print statement, which will print any expression result. And you can also have a compound statement which is inside a block, just like in C language. And these compound statements can be clubbed with conditional constructs. You can have a compound statement here, else another compound statement. Very simple if else conditions exist. And you have a while loop, for loop, and so on. I'm not really sure whether you want to use these features, but for simple arbitrary precision math, which with focus on automation, I think BC is a great tool to learn, right? So this is what you should know about it. And this is a POSIX compliant feature. It's not just found on Linux. You'll find this on macOS and with Solaris and many other Unix and Unix-like operating systems. So it's a standard Unix feature, right? I hope you find this video useful. So if you did learn something about this particular tool, please do share your thoughts on comments on the video. Thank you very much. So hope to meet you in future video sessions. Thank you.